So in this video, we are going to understand REST APIs. Why are REST APIs important? Well, if you are working with LLMs, it's definitely very important to understand and use REST API on a daily basis. So REST APIs, the full form is Representational State Transfer, and API is Application Programming Interface. These are a set of rules and conventions for building and interacting with web-based services. They enable different software applications to communicate and exchange data over the standard way, over the internet in a standardized way. Now, REST APIs are widely used to create connections between servers and clients, allowing them to send and receive information seamlessly. REST APIs are built on the principle of HTTP protocol, which is the foundation of the World Wide Web. They utilize HTTP methods such as get, post, put, delete to perform actions on resources identified by URLs. It supports different formats such as JSON or XML. Now, the principles of REST API architecture are as follows. Client server. It separates the client, which is the user interface, and the server, which is the data storage. And it allows for independent development and scalability of each component. Statelessness is another important thing. Each request from a client to a server must contain all necessary information, and the server should not store client context between requests. This promotes scalability and simplifies server management. Resources. REST APIs expose resources, identity, or data as URLs, providing a consistent and intuitive way to access and manipulate data. The next is HTTP methods. REST APIs use standardized HTTP methods such as get, which is a retrieve function, post, which is to create something, put means to update something, and delete means to remove something to perform actions on resources. Uniform interface. A uniform interface simplifies interaction by using consistent convention for naming resources, using standard methods, and following a predictable structure for URLs. Cacheability. Responses from the server can be cached to improve the performance and reduce network traffic, enhancing the efficiency of API interactions. We have a layered system where REST APIs can be organized into different layers, where each layer has specific functionality and responsibility. This separation promotes modularity and scalability. Now, these principles collectively define the architecture of REST API, and they promote simplicity, scalability, and compatibility across various applications and systems, and they serve as a foundation for designing efficient and effective web services. Now, if you ask me why are they important, they're used to provide a standardized way for developers to access and interact with web-based resources and applications. For example, let's consider a weather forecasting application that provides the real-time weather data for a particular location. The application can use the REST API to access the data from the web server that provides weather data for the various locations. The REST API would allow the application to send requests to the server and receive responses in a standardized format such as JSON or an XML format. This way, developers can build reliable applications that consume and utilize data from remote sources without having to worry about the underlying protocols and communication mechanisms. Now, let's go ahead to the Visual Studio Code Editor and check out for ourselves how we can easily implement the REST APIs. And also, I'm going to give you an example from the NVIDIA NIMS that's going to be interesting. So let's move on to the Visual Studio Code Editor and let's code it ourselves. Start up a new environment. So I am going to go to my terminal here, new terminal, and I am going to check the terminals or the environments that I have. So for that, you need to install Anaconda first, or if you don't have Anaconda, you can go with VENV virtual environment as well. So using Anaconda, the process is like this. I would say conda info-envs. So this will give me the list of environments. I will work with this test environment here. So okay, so I have this Python notebook created just for you, and once I open this app.ipynb, I can select the environment here, a kernel here. So select another kernel, Python environments, and I can select the test environment that I have created for this video. Now let's start up. So I install the request library. Now after I install this, we need to restart the kernel. Okay, restart the kernel, and all variables will be lost, but it's okay. We are working on Python 3.12. So I import a request and import JSON. I run this piece of code. Then I have this endpoint. This is the URL to which we will send our requests. So this is the URL, and we are sending request.get command to the endpoint that we have. So this is the response here. So I run this, and that's it. We have the response now. Now let's print out different things. Let's print out the response itself, and then print out the response .json here, and then print out the json.loads response text here. So what it basically does is that we have an endpoint, which is the API, and that is the server part which is running on the server. So we send a request from the client side. So this is a GET request from the client side to the server, the URL of the server, and we get the response here. The response is a 200, meaning it was a successful response. There are other codes as response when you have unsuccessful, be it from the server side, from the client side. You have different numbers here, and then you can print out the entire response in the JSON format, which you can see here. So it's a JSON file. So next we can check out the type of the response and loads. We can see that it's a dictionary here. So that's a dictionary, and we can extract any meaningful things that we need from this response, which we will make it clear in the rest of the video when we have a more sort of a good example. So basically the structure is this: we import the library, we have our API key here. Now in terms of authentication, we have seen that when we send a GET request, the first is the URL to which we want to send the request, and then we need to put in something known as headers, which has different key value pairs. But for this example, we have this API key. So we put in your API key here, and the authorization is bearer plus the API key, and then we send a GET request to get the response. So this structure is used for authenticating your request, because it's very essential that when we have a background service running on the server side, we need to authenticate who the client is, so that you can have a tracking and control over your service. Now this is an example of a rate limiting request. So as always, we imported the request, we import the time, and this is a URL, and let's say the request per second is 0.2. So this is what is allowed, let's say. So every 5 seconds we allow one response to be generated. Okay, request per second is 0.2. So for a single request, we need 5 seconds. Initial request counter is 0, and the maximum number of requests that you can make is, let's say, 4. So total, in order to complete the 4 number of requests, we would need 20 seconds, because for one request we need 5 seconds, because this is request per second, and in 5 seconds you would be able to get one request. So if we run this, we make a make request function. So define a function make request. This will take in the URL, and it will send a get request. So URL is the same thing that we have already defined, and if the status code is a 200, which is if it's a success, then we print out the data here, and if it's an error, we print out the error and the response status code of the error. So we start up or initialize this function. Next, we create a while loop while the request counter, which starts from 0 if the request counter is less than the maximum number of requests, which is 4 in our case. So we want 4 requests to be sent. Start time is a variable, and we start up this variable. So time.time, this is the start time. We ask to make a request here. We make a request, and then we increase the request counter here. So request counter plus equal to 1. So this will increment the request counter. Then we calculate the elapsed time. So what is the time right now minus what was the start time. So this was the elapsed time, and we print the elapsed time. Time to wait. So let's say it was able to print very quickly, and if it prints very quickly, it would have to wait. So time to wait is 1 byte request per second, which is request per second is 0.2. Therefore 1 byte request per second is 5. So 5 minus, let's say it took 2 seconds to generate, so 5 minus 2 is 3 seconds. So it will wait for 3 seconds for the next generation to start. So if it's a positive number, then it will wait for the time to wait. So it will sleep for the time to wait. Let's make it more clear if you run this. So we run this, and we see that we need 1.5 seconds to generate one request, and it waited for 3.4 seconds because total 5 seconds was allowed. So every 5 seconds we allowed only one generation. Therefore, even if the answer or the response was obtained in 1.5 seconds, it waited for 3.4 seconds because we allowed a single request to be sent in 5 seconds. So we got 4 such requests, and this is an example of the rate control. It's very important to have a rate limited request to the server so as to balance the load in the server and not to overload the server side. Now this is another example from the NVIDIA NIMS. So if you go to NVIDIA to NIMS service, we can go and click on try now. Once you go on try now, we need to log in with your account here, and let's go to this Mistral 8x22B instruct model, and here I can go to this shell command here. Then you can see some sort of an advanced features here. So for example, we have this URL, so I copy this URL to this location, and then in terms of header -h, I have content type application JSON, and this authorization I have bearer and the API key. So you can just click on the API key here, copy the API key and put it here. So this is the API key, and then we define the payload. So the payload is first of all the model here, then the message here, then we have the temperature, top P, max token, and stream is equal to true. So we have the payload here, and once we have this, we can start this up. Next, what we can do is that we can get the response using a post request to the URLs, putting the headers and putting the payload here and putting stream equal to true. Now if you get true or status code equal to 200 response, which means if it's a success, then what you can do is for line in response.iter_line, so we will iterate by line-wise iteration for the results. So if we have a result in the form of a response in the form of 4 lines, let's say, so we'd go line by line. So if there is a line present, we would decode this from the UTX. We'll decode the line to format, and then if the line starts with data, we will neglect the first 6 characters, which means these characters will neglect, and then we would get this response. So we would have this part of the response only, and then what you can do is you can go and convert it into a dictionary. Once we convert it into dictionary, then we can find that choice in data, and if it's there, then we can extract it in this format and get the full content, which was initialized to an empty string here. We add the content and then print the content at the end. So if I run this, it will make more clear. We will see the output in just a second. So we see that the question was why is the sky blue, and you can see that the sky appears blue due to a process called Rayleigh scattering. We have the full response here. Now this is a pretty complicated and a good example of how to use the REST APIs. We started from the basics, got to know how to construct an API, what are the parameters that is required. So we have URLs, we have headers, we have payloads, and nothing gets more complicated than this. You have the URL, you have the headers where you have the authentication APIs, then we have the payload, different type of model, for example messages, temperature, and other parameters that you will define for the model. We can put in stream equal to true. If stream equal to false, then you'll get a complete response, one instance, and you can just print the entire response. But for working with LLMs, we need to understand how to work with streaming data, because it gives a good feel for the customer when we have a streaming response, because the first time to first token is when you get the response, and if you wait for the entire response to appear before you show it to your customer, they would be bored and would not appreciate the app. But stream equal to true, as with all the chatbots that you see, the OpenAI, they have stream equal to true, and it gives a more realistic and good feel. So having said that, I think you got to understand all the complexities from 0 to 100 for the REST APIs, and I'm sure you like this video. So if you like this video, please subscribe and hit that thumbs up button so that I can make more videos just like this for you. It's a simple video, but it's very essential when you are working with LLMs, because this is the time for AGI, and I want each and everyone to participate in this. Thank you. Have a nice day.